Hi guys. So as a follow-up, I just want to review what we did today in class. We practiced compound inequalities. And these are inequalities that have more going on than our basic inequalities. We had two types. We had an and inequality, which I talked to you was kind of like a sandwich, okay? Where the x, the variable, was in the middle of two inequality symbols. So here's my two inequality symbols. Remember, the inequality symbols cannot point towards each other. And so we would solve it simultaneously. So we subtract 1 from everything, and we get -4 is less than x less than 4. Actually, we did this the other day, didn't we? All right. We also have our compound or inequalities, which are two separate inequalities that are separated by the word or, because it means that one of them can happen or the other one. Okay, so the first thing that we do is we solve each one just like we would a regular inequality. So we do backwards PEMDAS and we isolate our variable. So we subtract 5 from both sides. Okay, and then we get 3x is less than or equal to 1 minus 5 gives me -4. And then we divide by 3. Okay, all right, then we go to the other equation. We don't want to forget that or has got to be part of my answer. So here we have x is less than or equal to -4/3 or -1 1/3. Or we subtract 8 on both sides, isolating our variable, and we get -x is less than -3. Okay. But when we're solving an inequality, we always want a positive value for our variable, so we divide by -1. So x is, when we divide or multiply by a negative to an inequality, we have to flip the symbol, and we get -3 divided by -1, which would give me 3. So my answers are, and my or has to come with me because it's part of my answer. I either have x is less than or equal to -1 1/3, or x is greater than 3. This concept of inequalities with the compound inequalities, we're going to use now to solve absolute value inequalities. So let's look at what I mean. There are two types of absolute value inequalities, okay? There's the less than ones, and when I say two, I mean less than or equal to as well. And there's greater than. Oops, I'm spelling wrong. So greater than. And when I say greater than, I also mean greater than or equal to, okay? So first I want to talk about that. The less than inequalities, we're going to treat them as and compound inequalities, okay? And the greater than ones, we're going to treat as or compound inequalities. And if you want to help yourself, instead of spelling greater with an ER, spell it with an OR, spell it wrong, and it may help you remember that the greater than ones we're going to treat like or inequalities. Okay, so first, let's read. Let's see how this is read. How is x with a symbol and 6 read? That would be read that x is less than 6. X is less than 6. So now I want us to ask yourself how this is read. Okay? This is actually read the absolute value of 3x minus 4 is less than or equal to 2. Okay? The absolute value of 3x minus 4 is less than or equal to 2. I always told you, always read it based on where x is. With an absolute value, you always read it based on where is the absolute value bars that we were talking about yesterday, where they are, okay? All right, so how do we solve these equations? Let's talk about it. Absolute value, we're going to call them and inequalities. Just like our compound and inequalities. And we know that and inequalities are sandwiches, okay? So the first thing we do, we have to create a compound inequality. But before we do that, we don't want to forget our rules with absolute values. First, we need to always isolate the absolute value bars. Okay? Meaning they have to be all by themselves on the left side. Okay, so they are isolated in this case. Okay, so then step one would be, that would be step one. Step two would be to create a compound inequality. To create a sandwich inequality. Now remember when we talked about absolute value yesterday, we said that absolute value is the distance from a number on a number line, distance between two values on a number line. And distance always has to be positive, but you could still go in the negative direction. So this is going to be the same idea. How do we create a sandwich? Well, we take the expression out of the absolute value and we write it. But a sandwich means I need something on the other side, and remember we can never point the inequality symbols towards each other. So we put an inequality symbol on the other side, and we also have to consider the negative value. So I took the 5 and I put negative 5 on the other side. So I've created an and inequality, and then we solve it just like we would with a regular compound inequality. So we are going to add x, solve it simultaneously, okay? All right, and we get x is greater than 1 and less than 11. All right, so now we have to graph it. Now, we've talked about this, that the majority of the absolute value graphs are going to be graphed on a number line between the 2 points, 1 and 11, okay? So we've got x is greater than 1, less than 11, open circle, and I want everything in between it, just like a sandwich, where the numbers on the outside act as my bread, and the x acts as my meat, okay, or my peanut butter and jelly. All right, so there's my absolute value answer. This part, and then the graph, okay? All right, so now let's try a harder example. Harder example. All right, so we look at it and we read it to ourselves. 2 times the absolute value of x plus 1 is less than 4. Okay? So for myself, I already know it's less than, and you know how Coach Fred likes to do this. Less than means it's and, okay? So it means I'm going to be making a sandwich. All right, but first, step one with these absolute values is always going to be to isolate the absolute value bars. So we have to get rid of this 2. We divide it to the other side. We're not going to distribute it through the x plus 1 because those are not parentheses. All right, this cancels, and we now have the absolute value of x plus 1 is less than 2. Okay, so then we create a sandwich. So we take what we have out of the absolute values, and we write the negative value on the other side. So now we have a sandwich in between 2 and negative 2. We solve it simultaneously, so we subtract 1 from both sides. And we get negative 3 is less than x is less than 1. And then we graph it. Come over here and graph it. And again, my sandwich, my number line is going to be a sandwich with the negative 3 and the 1. And I want all the x's in between those two values, okay? All right, so how are we doing? Let me just check the time as promised. I'm trying to keep these a little bit lower. All right, let's start by looking at one that is greater than, okay? The second type of absolute value inequalities is an or inequality. And again, it's going to be when the absolute value is greater than a number. So let's read this. This example is read, the absolute value of 3x minus 8 is greater than 5, okay? So step one is still to isolate the absolute value bars, okay? Which it's already in that form. But now that it's an or inequality, remember from what we warmed up with, that or inequalities are two separate inequalities with the word or in between them. So what I do is I take my first inequality out of the absolute value bars and I just write it as it's given, okay? Then I write the word or. Now I have to write a second inequality. So you keep what's inside the absolute value bars. You change the direction of the inequality sign. And you change the 5 to negative. So you keep, change, change. You KCC it. Keep, change, change. Now you've got an or compound inequality and you solve. So you add 8 to both sides, so you get 3x is greater than 13, and then you divide by 3. So x is greater than, what is that, 4 1/3. Or, changing colors, you add 8 on both sides, and you get 3x is less than, -5 plus 8 is 3, and then you divide by 3. So x is less than 1. Sorry, I ran out of room there. Then we graph it. I'll graph it over here. So we have x is greater than 4 1/3. So here's 4 1/3, and here's 0 down here. And here's 1. Okay? So I want x is greater than 4 1/3, and x is less than 1. Notice the graph. Okay, now this is not always going to be true, but in the short term, I want you to think about how the OR graph looks different from the AND graph. The OR graph is pointing out, okay? And I'm going to talk about when this won't happen, but for now, let's make sure that our OR graphs always point out, okay? So we're going out instead of in between the two sandwiches like in the less than graphs, okay? All right. So what I'd like you to do is I'd like you to try this next one. X minus 4 plus 1 is greater than 3. Now remember, it says greater than, so I know it's an OR graph. Okay? So try it, pause, and then come back, and I'm going to do the work. Okay? So press pause now and try it. Okay, so step 1 would be to isolate your absolute value. So we get x minus 4 is greater than 2. Then we know that it's an absolute value greater than 2, so I need to make a compound inequality with the word or. I keep exactly what I have, just take it out of the absolute value bars. And on the other one, I do x minus 4, I keep what's in the absolute value because you never change what's in the absolute value, never. And then you change the direction of the inequality and you change the sign of the number. You solve each one individually. So by adding 4, I get x is greater than 6, or, and by adding 4 here, I get x is less than 2. I graph it on a number line. I have x is less than 2, so here's 0, 1, here's 2, 3, 4, 5, 6. I want x is less than 2, so going to the left, and x is greater than 6, going out. So hopefully you got that one right. Tomorrow in class, we're going to spend some time practicing all of this, and I will review everything in class tomorrow, okay? All right, have a great night. Bye-bye.